Hello, my name is Makiba. We are Team 5, and we will be presenting a scheduling linear program. The objective of this program is to help Gotham Bank minimize its labor costs whilst maintaining adequate teller staffing in order to provide quality customer service to its patrons. The given information in the problem lets us know that the bank has normal operating hours from 9 a.m. to 5 p.m., which is an 8-hour window. They're open 5 days a week, Monday through Friday. They employ full-timers and part-timers. With respect to full-timers, they receive a 1-hour lunch from either 12 to 1 or 1 to 2. They get paid $8 an hour, which equates to $64 a day. With respect to part-timers, they're allowed to work 3 consecutive hour blocks only and receive no fringe benefits or lunch. They get paid $5 an hour, which equates to $15 a day, and the bank can only hire 5 part-time employees at most. Based on historical data, the bank has provided a table which indicates its daily staffing needs based on the hour blocks. And as you can see, the time periods are 1-hour segments. Now, Alex will go over our decision variables, objective function, and constraints. Sorry,
So,
Eric.
yeah, with all of the problem laid out, with all the information laid out for a problem, we were able to define our decision variables. So, starting with x1 and x2, which were given to us in the problem, we have the number of full-time tellers with their lunch from either 12 to 1 or 1 to 2. And then we have laid out each of the part-time workers that will be starting at each of the given hours. With that, we can then create our objective function where we want to minimize our z equation. So we have 64, which is the cost of the full-time workers over their 8 hours, times the x1 plus x2, the full-time workers, plus 15, which is the cost of the part-time workers over their 3 hours, times each of the part-time workers. With our constraints, we start and go through each of the given hour segments. So starting with the first, we have X1, X2, the full-time workers, plus the one part-time worker that can work there. And they cannot exceed more than 4, or they cannot be less than 4. And then we follow that format through the hour segments until we get to the 12 to 1 and 1 to 2, where we take out either the 12 to 1 lunch or the 1 to 2 lunch, depending on when they take their break. And then at the end, we have each of our part-time workers being added together to not exceed more than 5. And we have our non-negative constraints, so everything has to be positive.
Hello, I'm Alex, and I will be going over the programming section of the assignment of this presentation. Um, for the program, we first define all the variables, the full-time and part-time. We are using an integer format as we want a real-world answer. And if we use the float or a different type of variable definition, it would give us a fraction, and we can't have fractional employees in real time. Afterwards, we also created the minimize function, which is just the objective function we created, and we subject that to the constraints we also created. If we run this program, we get the following values at the bottom left. It shows that the full-time worker that has lunch at 12 has 2, and then the full-time worker that has lunch at 1 has 4, and then the part-time worker is at 2 p.m. that starts at 2 p.m. has 2 workers needed, and then at 11 p.m. has 3 workers needed. In conclusion, in order to minimize the daily teller costs, the Gotham Bank should have 11 total employees working daily. 6 will be full-time workers, where 2 are scheduled to start their lunch at 12, and 4 are scheduled to take their lunch at 1. The remaining employees would be part-time, where 3 would come in at 11 to 2 p.m., and 2 would come in from 2 to 5 p.m. And the daily cost associated with this scheduling plan would be $459. Thank you for your time. That is the end of the presentation.